What if I told you that everything you can see, every star, every galaxy, every planet, and even your own body is all resting on a single sheet, a flat surface floating in an enormous space, and within that space there may be countless other sheets, entire universes existing right beside our own, perhaps only a few millimeters away, yet we can never see them, never touch them, and never know they are there directly. Even more surprising, gravity, the force that keeps us firmly on the ground, may actually be leaking away from this sheet. It sounds like the beginning of a science fiction story, but it isn't. It comes from mathematics. The equations of modern physics suggest exactly this possibility, and, with one extraordinary idea, they offer potential answers to 4 of the greatest mysteries in physics all at once. What existed before the Big Bang? Why is gravity so much weaker than the other fundamental forces? What is dark matter? And how did our universe truly begin? Tonight, we'll gently explore this story from beginning to end, following a theory that proposes our entire reality is nothing more than a membrane, a vast sheet that scientists call a brain. To understand this idea, we first need to begin with something very simple, yet incredibly important. When we look into the night sky, we see stars scattered across the darkness. When we look deeper with powerful telescopes, we discover even more galaxies stretching far beyond what our eyes alone can see. Naturally, it feels as though we are observing the entire universe. But in reality, we are not seeing the universe as a whole. We are only seeing a bubble, a vast bubble surrounding us, beyond which we simply cannot observe anything at all. Why does this bubble exist? The answer lies in the speed of light. Light travels incredibly fast. In 1 second, it moves approximately 300,000 kilometers, fast enough to circle the Earth several times in that brief moment. Yet no matter how astonishing that speed may seem, it is still not infinite. It has a limit, and that limit quietly shapes everything we are able to observe. When you look at the moon, the light entering your eyes left its surface about 1 second earlier. That means you are seeing the moon exactly as it was 1 second ago. When you look at the sun, the light began its journey about 8 minutes earlier. So you are seeing the sun as it existed 8 minutes in the past. And when you observe a galaxy located 100 million light-years away, the light arriving today actually left that galaxy 100 million years ago. In other words, every time you look into the night sky, you are also looking backward through time. Now extend that same idea to the entire universe. Our universe is approximately 13.8 billion years old, which means light has had only that amount of time to travel toward us. If a galaxy is so distant that its light would require more than 13.8 billion years to reach Earth, then we simply cannot see it because its light has not yet arrived. This creates an enormous bubble surrounding us, measuring roughly 93 billion light-years across. This is what scientists call the observable universe. It is important to understand that the boundary of this bubble is not a wall. There is no place where the universe suddenly ends. It is simply the point beyond which light has not yet had enough time to reach us. Beyond that invisible boundary, there may still be galaxies, stars, and planets, but they remain hidden from our view. This is not because our telescopes are too weak or our technology is limited. It is one of the fundamental rules of physics, a limit that no amount of engineering can overcome. That naturally leads to another question. If we can never see beyond this bubble, how could we possibly know what exists outside it? The answer begins with mathematics. But before we can understand that mathematics, we first need to imagine a very different kind of world. At first, it may sound unusual, but if you simply follow the idea, everything that comes afterward will become much easier to understand. Imagine a world that is perfectly flat, like a sheet of paper. The beings living there have length and width, but absolutely no height. They are completely flat, almost like drawings on a page, able to move only forward, backward, left, or right. For them, the ideas of up and down simply do not exist. Their minds cannot even imagine such directions because they have never experienced them. It is much like trying to describe the taste of salt to someone who has never tasted it. No matter how carefully it is explained, the experience itself cannot truly be imagined. In exactly the same way, for those flat beings, height is not merely invisible. It is a concept that simply does not exist anywhere within their reality. Now, imagine gently pushing an apple down into that flat world from above. Those flat beings would never see the entire apple because they have no ability to look upward. They could only perceive the thin slice passing through their flat world. At first, a tiny circle would suddenly appear. As the widest part of the apple moved through their surface, that circle would gradually grow larger. Then, as the apple continued on its way, the circle would slowly shrink until it vanished completely. To those flat beings, this would seem like an impossible and deeply mysterious event. A circle appeared from nowhere, grew larger, became smaller, and then disappeared without leaving any trace. They would have no explanation for what they had witnessed, because the real explanation exists beyond everything they are capable of perceiving. A three-dimensional object simply passed through their two-dimensional world, but they have no awareness that a third dimension even exists. Now pause for a moment and think about that. It is easy for us to smile at those flat beings, believing their understanding is limited because they cannot imagine up and down. But what if something remarkably similar is happening to us? We are familiar with three dimensions: length, width, and height. We can move forward and backward, left and right, and up and down. But what if there are fourth, fifth, or even sixth directions that movement is possible through, and we simply have no awareness of them? Perhaps we cannot even imagine those directions, just as those flat beings could never imagine height. This may sound like science fiction, but it begins with mathematics. The year was 1919. A physicist named Theodore Kaluza took Einstein's equations and solved them using 5 dimensions instead of 4, and the result was astonishing. The moment he added an extra dimension, the equations naturally began describing both gravity and electromagnetism together, something that had never been possible within 4-dimensional mathematics. Kaluza carefully wrote down his work in a letter and sent it to Einstein. At first, Einstein was amazed, but he was also somewhat unsettled. The idea was so bold that he kept the letter to himself for nearly 2 years because even he found it difficult to believe. Finally, in 1921, Einstein helped Kaluza publish the paper, and from that single idea, an entirely new possibility emerged that perhaps our own reality also contains dimensions that remain hidden from our senses. As the years passed, string theory and later M-theory expanded this idea even further. The mathematics suggested that the universe may not contain only 3 dimensions, but perhaps 10 or even 11. The 3 dimensions we experience every day could simply be the surface of something much larger, like a vast sheet floating within an enormous, higher dimensional space. For those flat beings, their sheet of paper represented all of reality. They had no idea that their paper rested inside a 3-dimensional room. In much the same way, we naturally assume that our 3-dimensional universe is everything that exists, while never considering that it too may be floating within an unimaginably larger, higher dimensional space. Physicists have given that larger space a name. They call it the bulk, while our own universe is known as the brain. The word brain comes from the word membrane. It describes a surface upon which our entire reality exists. Every galaxy, every star, every planet, every human being, and every atom exists upon this single cosmic sheet. Understanding this idea requires one more important piece of history. When physicists first introduced extra dimensions through string theory, they believed those dimensions had to be incredibly small, so tiny that they could never be detected. Imagine looking at a thick rope from far away. From a distance, it appears to be nothing more than a thin line, but as you move closer, you begin to notice that it is actually round. Scientists believed the extra dimensions were curled up in much the same way, folded so tightly that measuring them would be impossible. Then, in 1998, two physicists, Lisa Randall and Raman Sundram, were sitting together in a coffee shop in Boston, discussing how extra dimensions might change the predictions of particle physics. During that conversation, an extraordinary idea quietly began to take shape, one that would later become the foundation of one of the most influential papers in modern physics. In 1999, they published their work, and it transformed the way physicists thought about extra dimensions. Their mathematics suggested something completely unexpected. Those extra dimensions did not have to be tiny at all. They could be incredibly large, perhaps even infinite. Our universe could simply be one surface suspended within that immense higher dimensional space, much like a sheet floating peacefully on an endless ocean. Everything resting on that sheet remains confined to its surface, and anything living there would have no awareness of the unimaginable depth stretching beneath it. Our universe is that sheet, while the higher dimensional space surrounding it is called the bulk. Even more remarkably, the mathematics suggests that the bulk may contain not just one brain, but many countless parallel sheets, countless parallel universes, all quietly existing together within the same vast, higher dimensional space. Imagine many sheets hanging side by side on a clothesline, close to one another yet never touching. That is one way to picture these parallel brains. At this point, a very natural question begins to arise. If another universe truly exists beside our own, another brain occupying the same higher dimensional space, then why can't we see it? Why can't we feel its presence? Why can't we reach out and touch it? This is perhaps the most important question in the entire story, and its answer lies in something incredibly small, the tiny strings that, according to string theory, make up everything in our universe, including ourselves. Most of us naturally think that the smallest building blocks of matter are particles such as electrons, quarks, and protons, imagining them as tiny solid spheres, almost like microscopic balls. String theory suggests something very different. Instead of being solid points, these particles may actually be unimaginably small, vibrating strings. Tiny bundles of energy oscillating in different ways, so incredibly small that no instrument has ever been able to observe them directly. According to the mathematics, these strings possess a remarkable property that may determine the structure of our entire reality. The theory describes two kinds of strings: open strings and closed strings. Open strings have two distinct ends, much like a short piece of thread with a beginning and an end. The mathematics suggests that the ends of these open strings can never leave the surface of the brain. They remain permanently attached to it. They are free to slide across the surface in every direction, but they cannot lift away from it and travel into the bulk. A simple way to picture this is to think about the tiny hairs on the back of your hand. They can bend and move in many directions, but their roots remain anchored within your skin. In much the same way, the ends of open strings remain anchored to our brain. This leads to an extraordinary conclusion. Every electron, every quark, and every particle that makes up your body is believed to be formed from these open strings. That means your entire body is permanently connected to the brain itself. We are physically confined to this cosmic surface. We can move freely anywhere across it. But according to the theory, we can never step beyond it into the higher dimensional bulk. The idea becomes even more remarkable when we consider light. The particles of light, known as photons, are also described as open strings. They too possess two ends, and those ends remain attached to the brain. Light can travel across our universe in every direction along this surface, but it cannot leave the brain and move into the bulk. This single idea explains something profound. Why can't we see the bulk? Because seeing requires light, and light itself cannot travel there. Every observation we have ever made depends entirely on light. Our eyes rely on it. Every telescope relies on it, from Hubble to the James Webb Space Telescope. Every image of the cosmos has been carried to us by light that remains trapped upon our own brain. The key to this solution is a very unusual particle, one unlike every other particle we have discussed so far. It is not an open string. It is not permanently confined to the brain, and according to the mathematics of string theory, It is the only particle capable of leaving our cosmic sheet and traveling into the higher dimensional bulk. This hypothetical particle is called the graviton, and it plays a central role in the entire idea. In modern physics, every fundamental force is associated with a particle that carries it. The electromagnetic force is carried by the photon. The strong nuclear force is carried by particles called gluons. In the same way, gravity is expected to be carried by a theoretical particle known as the graviton. Although no experiment has yet detected a graviton directly, the mathematics strongly suggest that such a particle should exist. What makes it truly remarkable is its shape. Remember that electrons, quarks, and photons are described as open strings, each with two ends that remain attached to the brain. But when physicists examined the mathematics describing the graviton within string theory, they found something completely different. The graviton is not an open string at all. Instead, it is a closed loop, rather like an incredibly tiny rubber band with no beginning and no end, simply a continuous vibrating circle. That single difference changes everything. Open strings remain trapped on the brain because their two ends are attached to its surface. A closed loop has no ends at all. There is nothing to anchor it, nothing to keep it confined. As a result, the graviton is free to leave the brain altogether. It can travel through the bulk and move into the higher dimensions beyond our own universe. This possibility provides an elegant explanation for the hierarchy problem. Imagine a massive object such as a star or a planet generating gravity. According to this picture, gravitons are produced and begin spreading outward in every direction. But unlike photons or other particles, gravitons are not restricted to the surface of our brain. Because they are closed loops, they can escape into the bulk itself, spreading through the extra dimensions beyond our universe. A simple analogy helps make this easier to imagine. Picture spraying perfume inside a room. At first, the fragrance is concentrated nearby. But if doors or windows are open, the scent slowly spreads into neighboring spaces. As it disperses, the fragrance remaining inside the original room becomes weaker because part of it has escaped elsewhere. According to brain theory, gravity behaves in much the same way. It continually leaks away from our brain into the higher dimensional bulk, spreading into regions we cannot observe. As more of it escapes into those hidden dimensions, the amount of gravity remaining within our own universe appears much weaker. This is what makes the idea so appealing. Gravity may not actually be weak at all. When a star or a planet produces gravity, the total gravitational force could be every bit as strong as the other fundamental forces. We simply never experience its full strength because much of it escapes beyond our universe into the higher dimensional bulk. What we measure is only the small portion that remains confined to our own brain. In other words, we are not observing gravity in its full form. We are experiencing only a diluted fraction of its true strength. And now we return to the flat beings we imagined at the beginning of this journey. They lived upon their sheet of paper, believing it was the entirety of existence. They had no way of knowing that their paper rested inside a much larger room, or that only a short distance away there could be another sheet supporting another world altogether. Perhaps our own situation is not so different. The observable universe, stretching roughly 93 billion light-years across, may not represent all of reality. It could simply be one vast sheet suspended within an even greater space. And within that immense space, there may be countless other sheets, countless other universes, existing quietly alongside our own. They may be separated from us by only a tiny distance in a direction that we cannot point toward, cannot travel through, and cannot even perceive. Yet one day, as our understanding of gravity continues to grow, we may discover subtle clues hidden within gravitational waves or other phenomena that reveal their presence. If that day ever comes, it would completely transform the way we understand reality. We would realize that the universe we have always considered to be everything is only one small part of something far larger, while most of that greater reality still remains beyond our reach, waiting to be discovered. As our journey comes to a close, it is worth sitting quietly with that thought for a moment. Somewhere beyond the limits of everything we can see, beyond every galaxy and every horizon, there may exist other universes following their own histories, shaped by their own stars, and perhaps even their own forms of life. Whether that idea ultimately proves to be true or not, it reminds us how much of the cosmos remains unknown. Every generation has believed it understood the boundaries of reality, only to discover that those boundaries extended much farther than anyone had imagined. Perhaps our generation is standing at another one of those moments. Perhaps the universe is far stranger, far larger, and far more beautiful than we have yet learned to comprehend. And until the answers arrive, the questions themselves continue to inspire us to explore, to imagine, and to keep looking beyond the horizon of what we already know.